Hey folks, how's it going? This is Mr. Murray coming to you with a do now for May 4th, 2020, and may the 4th be with you. So make a table for this function and then answer the analysis questions. As a reminder, the domain, increasing and decreasing, are intervals of x values. The range is an interval of y values, and the vertex is a point. And remember, think about things like infinity and negative infinity in your answers. Alright, so go ahead, pause the video, solve this, and when you're ready, unpause, and I'll show you what I got. Okay, let's take a look. So this is an intercept form. Okay, you can see because, right, the idea is that whenever you multiply by 0, you always get 0. So I'm trying to do what I can to make this graph. I could plug in whatever I want. Look, the reality is you can always plug in whatever number you want. But let's just be honest. We want to get a nice outcome that's not going to require too much work, right? So I'm going to advocate for 2 and 8. And why is that? Because 2 minus 2 is 0. So you're going to end up multiplying by 0. So you get 0. It's a nice number to plug in, and you don't have to think too much about the answer. Now look, if I plug in 8 over here, I get 8 minus 8, and that's going to be 0. So I'm multiplying by 0, and I get 0. So I know 2 points off the bat. I know 2, 0, and I know 8, 0. And so what this tells me is that right in between, I have the vertex of 5. Excuse me. And so I now need to plug that in and figure out what I get. And remember, the vertex is always in the middle. But in general, if you have 2 points, you want to be plugging in numbers in between them. All right. First of all, outside won't even fit on the graph in this case, but you want to be plugging in between them. In general, if you can find what's right in between them, that is going to be the x of the vertex. So when I plug that in, I'm going to get 5 minus 2 is 3, because 5 is 3 more than 2, and 5 minus 8 is negative 3, because 5 is 3 less than 2. And I'm going to do 3 times negative 3, which is negative 9, times negative 1/2, which is positive 4.5, or positive 9 halves. Okay, so I'll put that at about right here. And then remember, because you have the vertex, you have that nice symmetry. So all I need to do is choose one point that's a little bit smaller than 5, and then go the same amount greater than 5. So for example, I'll pick 4 and 6. And because 4 and 6 are each 1 less or 1 more than 5, that is, they are 1 away from 5, they will always have the same y value in this case, okay, because the vertex is 5. So all I got to do is plug one in, and I'll just do 6. 6 minus 2 is 4, because 6 is more than 4. And it's, 6 is 4 more than 2. And then 6 minus 8 is negative 2, because 6 is 2 less than 8. And then I've got negative 1/2. So I've got 4 times negative 2, which is negative 8, times negative 1/2, which is positive 4. So 4 goes with 4, and 6 has to also go with 4. Okay, and if you don't believe me, that's okay. Plug it in. Oh, I want a redo on that. I demand a redraw. Okay, that was before your time, kids. Sorry. Okay, a little bit wider than your typical parabola, and that's because of the negative 1/2. So we have the negative, which makes it a frowny face, and we have 1/2. We're just going to go ahead and it's going to make it a little wider, because what it does is, if you think about it, it takes the y value that we thought we were going to have. Imagine if that 1/2 wasn't there. Then instead of being 4, forget the signs, it would be 8. It would be a lot closer to 0. So the effect of the negative 1/2 is that it's taking what we were going to get, and it's cutting it in half, meaning making it closer to 0. Not necessarily bigger or smaller, because I'd argue if you're cutting a negative number in half, you are actually making it bigger. I would argue, right, because like for example, -4 is more than -8. If you cut your debt, so if I owe $100 on the credit card, if I now owe 50, I'm in a lot better situation, right? Okay, so that's some of the ideas here. Let's go ahead and talk about the analysis. So the domain is -infinity to infinity, and that's what the domain is always going to be for a quadratic and for anything this year. The range. So if you take a look, let's go ahead and let's build out. You could take your pencil, maybe lay it down on your graph, or you could take a nice straight line and draw it out. Take it, and if you move this line up, you can see that, okay, here's where, so we can go up, we can go up, we can go up, and then all of a sudden when we get here, right, there's no more graph. The graph stops. So the y values for this graph are -infinity, and again, the arrows pointing down are also an indicator of that -infinity to 4.5, and remember we put a hard bracket on there because it gets to 4.5, and that's at the vertex of 5, 4.5. Okay, where is it increasing? Where's the roller coaster going up and down? So it's increasing from when x is -infinity to when x is 5. Now here's what I'm going to ask you. Is it increasing before the vertex or after the vertex? Are we going uphill before the vertex or after? We're going uphill before the vertex. This means before the vertex, right? Because the x of the vertex is 5. Where are we decreasing? We're decreasing from 5 to infinity. And that is after the vertex. Okay, so ask yourself, am I going up before the vertex or after the vertex? Before the vertex is the -infinity, right? Because -infinity is like before. Okay, so hopefully you were able to get a lot of this right, and you were able to find this to be helpful. Please do keep in mind I am planning to continue to move on in the coming days, and that will include essentially beginning to wrap up this unit by talking about how do we change from one form to another. And we might not have numbers like a half in front of there. I'm not quite sure about that, but we do need to start thinking about, well, if I was in standard form and I wanted to graph it, well, what if I could put it into intercept form? Because standard form, you can't find the vertex easy or the intercepts easy. So imagine I could turn it into standard form, rather in a factored form. So I could take standard form, turn it into factored form, and get the intercepts and vertex just using the method we just did. That would be really great. And so those are some of the kind of strategies we're going to investigate. All right, so keep it up, folks. I'm looking forward to some more great work from you this week. And remember, you can do it. All right, thanks for watching, and I'll see you next time.